This is how to find out if somebody's lying with statistics. I understand that this comment was specifically targeting me, saying that I lie with statistics, but I figured this is a good time for an educational lesson. And if you don't trust me, that's totally fine. Don't take my word for it. I strongly encourage everybody to learn about statistics and how they work so you know who's lying and who isn't. But anyway, our first example is measuring the increase of percentages. Let's say last year college dropout rates were at 10%, but this year it doubled to 20%. Is that a 10% increase or is that a 100% increase? And the phrasing matters a lot. There are going to be a lot of people who say, oh, it was just a 10% increase, not anything to worry about, even though it literally doubled. But the thing is, both of these are technically right. It is a 10% increase of college kids, but it is a 100% increase in the dropout rate of these college kids. And so in a lot of instances where percentages change, phrasing can actually have more of an impact than the actual numbers themselves. And this is why I personally like to use phrases like doubled instead. And that kind of leaves the ball in the viewer's court as to how important that number is. Whereas if somebody said it only increased by 10%, that's kind of misleading. Now let's look into topic number 2. We're going to talk about percentages versus totals. Very commonly, people who try to lie with statistics like to say things like New York has more crime than any other city. And the reason that they're able to say that factually is because New York is the most populous city in the country. If New York is twice as populous as the city that it's being compared to, that means it also has double the amount of people who potentially can commit that crime. And it also has double the amount of people who are potentially not affected by those crimes. And as a result, we need to adjust for population. And when we do, we find out that New York is not really on any of the most dangerous lists. Your chance of being a victim of violent crime is not anywhere near close in New York as it is to a place like Memphis. And here's the thing, population isn't the only thing that we adjust for. A little less than a week ago, one creator tried to correct one of my videos by saying that Montana has more wind energy production than Rhode Island does. And while that number is technically true, it ignores a lot of context that's really important to that stat. Specifically, wind energy takes a lot of land to generate, and Montana is 145 times the size of Rhode Island, which means it has way more space to put windmills than Rhode Island does. Rhode Island is very densely packed and very small. Montana also has a much higher wind speed than Rhode Island does, which means it should be generating more energy per windmill than Rhode Island does. So in theory, even if we're discounting the wind speed, if we're trying to look for which state has the most focus on wind energy, we need to look at wind energy generated per square mile, in which case Rhode Island has quite a bit more. Rhode Island generates about 168,000 kilowatt hours per square mile. Montana, on the other hand, only generates 19,000. And considering the fact that a higher percentage of Rhode Island's land is dedicated to things like cities, and as a result, it's much harder to put windmills in Rhode Island than it is in Montana, the fact that Rhode Island generates way more wind energy per square mile means it's a bigger focus for Rhode Island than it is Montana. And speaking of context, if you're about to comment saying that that video was a bad comparison, yes it was. I say that in that video. That video was solely a response to a commenter not wanting to use per capita stats and wanting two states with the same population. I agreed that it was silly. And as a result, context was extremely important for that video as well, and if you were paying attention, you would have known that context because I said it in the video. And lastly, part 3, let's look at how to lie with graphs. I'm about to show you two graphs, both featuring robbery rate and breaking and entry rate. One of them is California and one of them is Texas. Now, without any context as to the numbers outside of these graphs, which one of these states do you think has the most of these two types of crime? The answer, of course, is California. These graphs make it look like California has much higher crime rates than Texas does. But now that these two graphs are side by side, take a look at the axis. Notice how California's axis only goes up to 300, but Texas goes up to 440. When you stop and look at these graphs, you can see that Texas actually has way higher burglary rates than California does. And California still has more robbery, although it's very close. So the very first thing to look into is obviously axis. Does the axis match what it's actually trying to say? But there are actually much more problems with these graphs than just the axis. First off, we're separating the two things that we're comparing in two different graphs. Texas has its own graph and California has its own graph, and if we're comparing Texas to California, they should share the same graph. And if we're not comparing robbery rate to burglary rate, then those graphs should be separate graphs. And if you're comparing two states with different values over and over and over again in quick succession, it's also important to have the top value in the same place every single single time. Look at these two graphs. While the axis is different because burglary and robbery need two different scales, you can very easily see the amount of difference in both of these stats in both states. Which is why if you notice in all of my other videos where I have a lot of graphs in quick succession, the top value is always at the same spot every single time. So if some things are closer together, then they look closer together, but when things are further apart, they look further apart. But if I was changing the scale every time based on like national averages, it would be very difficult to tell which state has the most of certain rates in rapid succession like that, and that's the entire point of those graphs, is to make that clear. And as you can see, some of these graphs are extremely close together, and some of them are really far apart, and anybody watching this video will be able to tell the difference between the differences in those values. And the thing is, even outside of this video, there are a lot of things that I haven't covered that can be used to lie with statistics. And that's why when you see a statistic and you hear somebody telling you that statistic, it's important to look at the math yourself and understand why they're telling you that and what phrasing they're using. When you see a graph, it's important to not just look at the graph, but actually examine the graph. And since there's quite a bit more that I can talk about, if you want me to make this a series, I absolutely can. If you want to see more content like this, like and subscribe. I'm on all platforms. Give me a follow on TikTok and Instagram.